Alright, good morning everybody. Welcome back to Mr. Chen's YouTube channel. So today I would like to talk about the quadratic functions for graphing. So three different types of way for making a graph of the quadratic functions. The standard form, the vertex form, and also the X-intercept form. Okay, so let's start it off with the basic quadratic function. Okay, like example 4 right here. So anytime that's given with the functions, so you want to find out the structure regarding the value of a, h, and k. So with the vertex. So the general form is given as y equals a times the quantity of x minus h squared plus k. So a would be the scale factor. It tells you whether the graph is stretching or shrinking. And then h, which is considered the horizontal phase shift. And then k would be the vertical translation. Well, it looks like this one is just a simple function, so it's only the value of a, which is -6. And if there's no given value of h and k, so that means h and k would be considered 0, 0. So using the vertex form, we started off with the vertex at 0, 0. And for those students might be wondering, how do we get more points? So it's always about the xy table. So started with the easy number, such as -1, 1, and -2, and +2. So plug in a number, so we got -6 times -1 quantity squared. So that'd be -6. So -6 times 1 quantity squared, it's also -6. As you can see that those positions are symmetrical. So -1, -6. And then 1, -6. And then -2, so plug in a number, so -6 times -2 quantity squared. So this number turns out to be -24. And the other one, so similar. So it looks like this one is all the way down. So the parabola, basically connect those three dots. And it shows the graph. Another thing is that define the domain and the range. So as you can see that the domain here, it covers to -0, positive, so it's all real number. For the interval notation, it's -infinity to infinity. And then for the range, it's from -infinity all the way to 0 with a bracket. Because that 0 is included. So always domain and the range is from the least number to the greatest. Okay, so now let's see another example right here. So this one, let's do the one involved with the vertical translation. Okay, so such as number 9. Okay, so for number 9, again, compare and contrast, find the value of a, h, and k. So the value of a, it's 1/3, so that would be considered the vertical shrink with the factor of 1/3. And again, there's no value of h, so h is 0, so k would be -5. So 0, -5, so down here on the y-axis. So 1/3, in order to find out the exact way for shrinking the graph, so we need to set up the xy table to get some position. So plug in 1, -1, once again, so we got 1/3 times 1 quantity squared minus 5, so it's 1/3 minus 5, which is -4 and 2/3. And then the other one similar, so -1 quantity squared minus 5, so it's 1/3 minus 5 again, -4 and 2/3. So plot the point, so 1, -4 and 2/3. And for the vertex here, so the vertex it's started at 0, -5, so the parabola is going to be kind of getting stretching horizontally, so it's getting a little bit flatter. Again, so another position that we want to find out, perhaps, the x-intercept. So in order to get the x-intercept, you want to set y equals 0, and then solve for x. So F5 on both sides, and then multiply by 3, so we got 15 equals x squared. Square root both sides, so we got root 15. So without the calculator, student might be wondering how to approximate root 15. So root 15, it's less than root 16, but it's greater than root 9. So this number is right between 3 and 4. So educated guess, so this number is about 3.4. Okay, so plot the point, 3.4, comma 0. And then the other side right here, negative 1, negative 2, negative 3, negative 3.4, it's over here. So basically connect the dots. As you can see that the parabola is getting a little bit wider. So again, define the domain and the range. So the domain, it's all real numbers. And then the range. So that will be from negative 5 included, bracket, all the way to infinity. Okay, so now let's see what else that we have for the next sections. So again, the next section here, so this one is just going back to the standard form of a quadratic function. So without this, with the standard form, so we can set up that the vertex, or we can complete the square to find out the vertex. Okay, so check it out, number 12. So let's start off with the general standard form of a quadratic function. So that one is written as y equals ax squared plus bx plus c. So compare and contrast the value of a, 1/2, b, negative 6, and then c is 10. So using the vertex formula, negative b over 2a. So the vertex formula is also the line of symmetry formula. So x equals negative b, so 6 over 2 times 1/2, which is 6. To get a value for y, so we plug in a number back to the original equation. So 1/2 times 6 squared minus 6 times 6 plus 10. So 1/2 of 36 minus 36 plus 10. So it's 18 minus 36 plus 10. So it's negative 18 plus 10, which is negative 8. So the one that we found, the vertex. Another thing is that the value of c, so which is 10, so that shows the y-intercept. So 0, positive 10, that would be the y-intercept. Okay, so making a graph template, x-axis, y-axis. So 6, negative 8. So down here in quadrant 4. And then the y-intercept, so 0, up 10. And also set up the line of symmetry. So once you get the line of symmetry, we can use the equidistance to find out the other point on the parabola. So according to the y-intercept, the distance from the point of the y-intercept to the line of symmetry, it's 5 units away. So let's count it. It's 6 units away. So that means the other side, it should be equidistant, 6 units away. So 1, 2, 3, 4, 5, 6. So it's all the way over here. Okay, connect the dots. Parabola. Another thing that you want to find out is that the domain. So it's, you can see that domain for the parabola is always from negative infinity to infinity. The range. So this one's from negative 8 all the way to infinity. Okay, so now let's see what else that we have for the other one. Okay, so going back to the vertex form. So let's deal with the one with the negative. Okay, so again, the vertex form, compare and contrast, find the value of a, h, and k. So a is negative 1. If a is being negative, so that means it's reflected over the x-axis. So it's a reflection involved over the x-axis. And then h, negative 4, k is 7. Okay, so plot the point. so in the second quadrant. And we do know that a is negative, so that means the parabola, so it looks like it's going to be upside down. So again, to get more points, so we want to set up the xy table. So going through the point right here, the vertex, we do have a line of symmetry. So anything that's getting close to -4, so -5. So -5 plus 4 quantity square. So that's -1 quantity square, which is 1. Times -1 plus 7. So that'd be 6. Okay, so -5, 6. And then again, equidistance, 1 unit away, it's on the same level. So that means at 3, 6, -3, 6, so that'd be another point. Connect the dots. So the parabola. So again, to find the domain, -infinity to infinity, and then the range. So that the range from the least to the greatest, -infinity, all the way to 7. Okay, so the final form that I would like to talk about for the quadratic function is the X-intercept form. Okay, so such as example 23. Okay, let's take a look at that. So the general form for the X-intercept form of the quadratic function is written as y equals, again, a. So instead of being x minus h quantity squared, so it's x minus p, the quantity, times the quantity of x minus q. So where p and q, those are the x-intercept. So first thing first, define the element a, -3, so it's going to be upside down, reflection over the x-axis with the vertical stretch with the factor of 3. And then the first x-intercept is -3. Second x-intercept is -1. The way to define them, you can always set that equation equal to 0 and then solve for x. Okay, so again, x-axis, y-axis, plot the point, x-intercepts. So the first one, -3. The second one, -1. And for those you might be wondering, how do we find the vertex for this? So we need to apply the midpoint formula to get the x value of the vertex. So it's about x1 plus x2 over 2. So it's -3 plus -1 divided by 2. So it's -4 over 2, which is -2. To get the y value, we plug in a number back to the original equation. So -2 plus 3, -2 plus 1. So it's -3 times 1 times -1, which is 3. So we got -2, 3. So which is all the way up here. Okay, so one thing just want to check right here. Okay, -1, 0 is supposed to be right here. Okay, so connect the dots. Okay, so that's a problem. So again, the domain, all real number, -infinity to infinity, and the range from the least to the greatest, so -infinity, and then all the way up to the position of 3 with the bracket. Okay, so thank you for watching the video today. So any questions that you have, you guys are more than welcome to put in the questions on the YouTube comment bar. Okay, so see you next time.